Video is to model how to show growth at starting value in multiple representations. So the essential question that I wanted you to answer with this task was so that I know where do you look and what do you do with the information to determine the growth and starting value in each representation. So on the next couple slides I'll walk you through what I would do with each representation and then the final picture. Now I know that many students already know this information, but I'm not convinced that every student does. So this was my way of indicating who's got this information and who doesn't. So I really need you to show me that you have it. I'm not asking you to do a video like this, so I need the final product to be clear of what your thinking is. Where do you look and what do you do with the information? So showing my understanding of growth and starting value in the rule, I'm going to look for the growth as the coefficient of x. So I'm looking right here, and I see that my growth number, my m value, is 4. For the starting value, I look to see what's being added or sometimes subtracted in the equation. So I look here, and that value is the starting value. So that tells me my b value is 3, growth and starting value in the rule. So looking at growth and starting value in a tile pattern. I see in figure 0 there are 3 tile. In figure 1 there is a new tile added up here, a couple tiles added on the side, and a tile added on the other side. So that is a growth of 4 tile. So I'll say it's increasing by 4. And then on figure 2, there's a tile added here, 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 and here. So again, there's a growth of 4. And for figure 3, from figure 2, 4 pieces have been added. So this indicates the growth in the number of tile is 4 tile every time there's a consecutive figure number. So the growth is 4. That tells me my m value is 4. For the starting value, when I look at the starting value, I'm looking here at figure 0. It starts at 3 tile. So that tells me my starting value is 3 tile, or in other words, the b value is 3. So now looking at growth and starting value in the table. We start off by looking at the growth in the x values. These values are each increasing by 1. Sometimes tables do not have an x value increasing by 1, so it's important to note that, whatever the growth is. The y values are increasing by 4 each time. So I know my growth, which is a ratio of the rise to the run, is the y change value of 4 to the x change value of 1. So the vertical change to the horizontal change, and that simplifies to 4. So that tells me my m value, the growth, is 4. For the b value, I look here at the point when x equals 0. What is the y value? That indicates my starting value, also the y-intercept, and that tells me that my b value is 3. So I just wanted to add on to this that if you look at the growth from one non-consecutive figure number, so from 1 to 3, there's a growth of 2, and from the 7 to the 15, there's a growth of 8. I can also indicate my ratio is an 8 to 2 ratio, and that also simplifies to the 4. Okay, looking at growth and starting value in the graph, I'm going to pick a lattice point. I'll pick the point at 1, 7, and draw a growth triangle to the lattice point up here. So I look at my figure numbers, and I see that the figure numbers have increased by 2, so that's my run of 2. The rise, the change in the tile, has gone from 7 to 15. That's an increase of 8. So the growth as a ratio of rise to run is a rise of 8 to a run of 2. That's a vertical change of 8 to a horizontal change of 2. That simplifies to 4, and that tells me my growth value is 4. For the starting value, I look for where that line crosses the y-axis, also referred to as the y-intercept. It's at the point 0, 3, so that tells me my b value, my starting value, is equal to 3. So this is the final product. It shows for each of the representations, rule, graph, tile, pattern, and table, how I would see growth and starting value. So I did growth in blue, so I can see that I look here at the coefficient of x to find my growth. I look at how many tile are being added each time, and I've colored them in, and I've indicated that my growth is equal to 4. For the graph, I look at a rise and run ratio, a growth triangle, and I indicate the growth is that ratio of rise to run, and my final growth is listed as 4. For the table, I've looked at the change in the x values, the change in the y values, and I've indicated my growth is the ratio of the rise to run changes, and therefore my growth is 4. For the starting value, which I put in red, I indicate where I look in the rule. I've indicated what I've determined from this. The starting value is 3. I've looked at my tile pattern and figure 1 or 0 in particular, and saw that the starting value is when b is equal to 3. On the graph, I indicated that I looked at the y-intercept. The starting value, then, that y-intercept of 0, 3, is indicating that b is equal to 3. On the table, I looked at where x is 0, what the corresponding y value is, so the point 0, 3, indicating my starting value is 3. Sometimes in the table the starting value is not already there, and you might have to work forwards or backwards to find that value, but in this case they were all present. So this is my final picture showing how where I look and what I do with the information there to find the growth and starting value in each of the 4 representations individually.